That's it, yeah. Nice. Looks like we are connected.
For half the cost of a.
We are connected. All right. Welcome, everybody, to the Audio Programmer podcast. And I'm glad to be here today. And I'm here with our special guest, Geraint Luff. How's it going, Geraint?
Hi, it's going good.
So Geraint Luff and I are good friends, and we've known each other for quite a few years. He's also one of the world's most renowned DSP engineers. I'm maybe embellishing that, but Geraint would underplay
Household
that.
name, yeah, worldwide,
yeah. He's a household name in the music industry, in the plugin industry for sure. And he's been doing this for a number of years. He's also going to be speaking at our event in London called API. It's called Audio Programmer Interface. So this is a new event that we're doing that's going to be happening in London. Our first event is on the 30th of August, and you'll be able to join in either in person in London at CodeNode, or you can also join us online, and you can find out more information about that on the link below. But he's going to be speaking at API. And can you just tell us a little bit about what your talk is about?
Yeah, so it's about well, Hilbert transforms, which is the thing you need to do to be able to do sort of bode frequency shifting, sort of getting those inharmonic sounds. And I think there have been a few questions recently in the TAP Discord about that. And as a programmer, I think we all hate doing something 3 times. So like the 3rd time we do it, we're like, I'm going to generalize this. And so yeah, I tend to, after it's come up a few times, I'm like, I wish I could just send people a link. And the way to do that is to do a talk or a blog post or something about that. But yeah, I think that there are some common pitfalls, and that if you go Googling for it, then there are some pre-baked coefficients and various other methods which like they have some flaws which I just haven't really seen discussed. And the principles behind it aren't that complicated. So going through the process of like what it is, how you kind of make something that fits those criteria, and the problems with some of the existing solutions, and then some relatively easy fixes, which I think, yeah, could be fun.
And for the layperson such as myself, how would you describe how a Hilbert filter is different from bog standard Butterworth filter, let's say?
Right. So the Hilbert filter is the idea is that it doesn't change anything that you can hear, but it lets you do sort of single sideband modulation. So if you have this a background in like complex numbers and stuff, there is this idea of positive and negative frequencies, and it's always a little unintuitive to try and think about what that is. Like maybe it's you've got like some waveform, but like is the sound traveling this way or this way through it, or that kind of thing. But there are a bunch of stuff that there are things that are easier to do, and we can do more creative effects if you can kind of untangle and get a slightly simpler form of the audio that's only going in one direction. And the Hilbert transform is the thing that lets you do that. So it turns a sine wave into like a continuous complex value. So it never actually sort of heads through 0 for a given frequency. And yeah, that opens up a few other things you can do. Yeah.
Interesting.
So
and so what? Go ahead.
I was just going to say it's not an effect like you stick a Hilbert filter on there and then it sounds different. It's an ingredient that you'll start with a Hilbert filter, and then you'll build on top of that. So.
And what types of things would you build on top of that?
The most obvious one is frequency shifters. So not pitch shifting where everything's going up by a fixed number of semitones, but going up by a fixed number of hertz. And that's really, it gives you these kind of inharmonic, slightly crunchy sometimes sounds. But it's also really useful for a bunch of other things you can do. If you do phasers and that kind of thing, tend to go up and down.
Mhm.
If you go up, you have to go back down again. But if you're working with complex signals, which you've generated with this filter, then you can have, phasers or flanges that only go in one direction, just kind of go that way forever. So that kind of barber pole flanger. There are wild and wacky creative things you can do with it beyond that as well.
Mhm.
But yeah, I think it's a sort of a bread and butter thing for a certain type of time domain processing,
Mhm.
which I think would be.
You said something interesting there, that it's not pitch shifting, but it's going up and down in hertz. Can you help me understand what the difference is there?
Yeah, so if you've got a note that's like, A440, then like the fundamental is at A440, the next harmonic up is at 880, and then my mental arithmetic runs out. But if you want to shift that up to a different note, going up to say 500 hertz instead, then that'll be the fundamental at 500 and the next one at 1000 and then 1500 and so on. So like they stay in this kind of like fixed ratio. And so for higher notes, the harmonics are further apart. We don't hear it that way because our ears are kind of very roughly logarithmic in the way that we get pitch. But that's how a pitch shifting thing works. Whereas a frequency shifter would be, instead of going up by a certain multiplying factor, you just go up by 60 hertz. So,
Right.
that would maybe put your fundamental to 500.
Mhm.
But then the second one is no longer at a neat multiple. It's at like 940 and then something else. So like the neat integer ratios get disrupted, and that's fun for sound design, amongst other things.
So when you say pitch shifting, you're talking about shifting to another fundamental. Uh,
Yeah. So pitch shifting is when it still sounds like a note
mhm.
at the other end. And this kind of frequency shifting is it sounds a bit more inharmonic. It's often used for percussion, that kind of thing. And yeah, I mean, it's you can kind of mix and match them. There are some really interesting pitch shifting methods that are based on using this kind of maths, but like on a few different bands in like a multi-band way. And it's versatile, but like kind of the starting point is always getting rid of like the negative frequencies going in the wrong direction,
Mhm.
so that you can so that you only have one frequency uh,
Mhm.
for each sine wave in your input.
Got it. So some people may know as well that you've written a open source pitch shifting algorithm that's
Mm.
out there that's actually quite widely used. So pitch shifting, of course, is something that many DSP engineers have tried or have approached as a problem space, and there are a couple pitch shifting and time stretching algorithms out there. And I know that maybe I've combined those those two problem spaces into one, but I was wondering what is so challenging about that space, and why is it there are only a few solutions that are out there?
Interesting. So yeah, firstly, I have definitely shot myself in the foot by giving two talks next to each other with really similar names. They are completely different. Like the frequency shifting stuff is very accessible.
Mhm.
Like it's actually if you have some grounding in a bit of complex maths, then it's possible to do. There were like analog circuit versions, that kind of thing. Pitch shifting is it's a tricky problem because the goal is to get something that is perceived as natural, and the way that we hear sound is very well, we kind of evolved it over millions of years, and it's rigged for like, hearing other people talking or animal noises and that kind of thing. So it's not always consistent, and it's also what the term is overcomplete, which means that like in a way you get more information out, you kind of overanalyze it. So that means there is no perfect solution to what you're trying to do. You always have to make compromises because it's the different frequency things, like the phases are never going to align in exactly the same way as they do in your input if you're like moving the frequencies around. Like, so there's a lot of fuzzy middle grounds in there, and picking apart the audio into like components that you can kind of move around is, again, it's ill-defined. There simply isn't enough information to do that correctly most of the time. So it's a world full of heuristics and like approximations to how we hear and that kind of thing. And then if you get close, then you can make something that's like good enough. But it is difficult.
Yeah, somebody had told me a while back that pitch shifting is actually like an auditory hallucination. It sounds like that's along the lines of what you're saying. Am I right in saying that?
Auditory hallucination. Interesting.
Auditory, maybe not hallucination. Hallucination implies eyes. Auditory illusion, maybe is better.
Yeah, I mean it's all an approximation.
Yeah.
Like if you're listening to music and you're like chewing, sometimes you can hear the pitch of something shift, and that's because like the same sound's coming in, but because of the pressure and everything, it's like resonating different bits of your ear, and that is giving you some input which you can never reproduce. There is no sound that will completely accurately emulate that will resonate all those bits of your ear in a different way. Like, so all you can do is figure out which bits are important and preserve those, and then try and fudge the bits in between. And there are well-known techniques for this, but there's also space for creativity and innovation, and that's sort of why I picked it as a subject.
Yeah, what is it that first got you interested in sound and in this area of computing?
I don't know. I mean, I think it's always been there, actually. So I was quite musically interested when I was young. I was sort of a 5-year-old, like banging rhythms on stuff, and I liked maths at school, but just because I don't know, it felt good. And then also my older brother was learning programming, and so my dad to teach me as well. And it was really basic, like sort of printing stuff to the screen for most of it, because I was like 8 or something. But yeah, sort of I had those 3 interests, and then gradually it turns out that they overlap quite a lot. I was learning math so I could rotate stuff on the screen, that kind of things. I had to learn trigonometry from my dad, because I wanted to draw things at angles. And then I found that, my dad again also was explaining like sine waves and harmonics of sounds and that kind of stuff. And then turns out you could just kind of write big numbers into like a file and then open it up in audio editors. And so that's what I was doing first. And yeah, really captivating this idea of, as someone interested in programming, interested in maths and music, the idea that you can do something mathematical and then hear it, which I found very like viscerally appealing. But it was always a hobby for actually for all the way through university, and then like the first bit of my career as well. So I studied maths at university. And then when I graduated, I was like, well, I could be a banker or a teacher. But I'd also been doing this programming as a hobby. So I went into programming, and I did a bunch of other like non-audio programming things. but I always had this this hobby of writing audio stuff on the side, and then around 2020, I don't know, I really bored and frustrated with my current job at the time, and took the leap to into the unknown to see if I could make a go of it as a profession, and it's worked out really well. And I have to say that the most influential part of that was I went to a meetup in London and shook your hand and joined the Discord, and as well as being a lifesaver of a social environment in the middle of all the lockdowns here in the UK. It's also just opened up a lot of stuff, community and contacts and recognition and everything. So it's been a great place that you've created.
Thank you. Thank you. And it's really a privilege to have you as one of the more active members that we have there in the Discord. And I really love and I'm really proud of what we, and I say we, meaning more than you and myself. There are other people, some here who are watching the talk now, and others that are in the Discord that have helped to make this community into what it is now. And I feel very privileged to be a steward. And I wanted to ask you a little bit about what it is that you like about the community, what it is that you find that of value that you get from being involved in our Discord.
So I think the first appeal was that like there were interesting questions going on. You know, this is because I was doing this as a hobby and I didn't have professional backing. Like there was a company I was meant to work for after graduation, but 2009 financial everything was just a bit of a mess. So it meant that I'd been just doing audio on my own for a while, and I'd been writing some like Reaper effect plugins. And you know, it's nice to be on a forum, but it's not quite the same as like feeling like there are people that you can connect with about this passion. And actually, it was a bit weird to have this solo interest that like no one in my life was as into as I was. So the first thing it gave me was just like other people who understood that this thing I love was really cool. And yeah, and then from there, you know, that's still the main thing, to be honest. The community and social aspect of it. Like, there's also been, you know, some projects that you sort of you've come across and got in touch and connected up and that kind of thing, and that's sort of, so you know, there are practical benefits as well, but like in terms of what, you know, what makes the heart glow, it's definitely just people who are also into audio, which I was missing for quite a while.
Yeah, I love that connection of just being able to go in there and feeling like we're just amongst people that no matter what your background is or where you may be in your journey, that we have that Venn diagram, and the big part of that Venn diagram is audio, and that no matter what your background is, that we can just come back to that. And one of the things that I really appreciate about our community is our ability just to, even if we come from different perspectives regarding other things, that we can just come back to that, and that we just focus around that, and all the other noise of everything else that happens in the world can just stay on the outside. And I do my best to help manage that, and you help manage that as well.
You made me a mod recently.
Yeah.
I've not abused that power yet, but no promises.
But the great thing is that it's very rare that we actually even need to discuss things, and we have over 10,000 people in there. And what I love is that most people, most of the time, are able to stay on task and keep things around audio. And things get a little bit tenuous sometimes, because I think that there is this balance of tension, right? Where it's great to have different opinions and different perspectives that are coming into a common place, and being able to discuss that with respect and keeping it on subject without going into personal insults and things like that. But so it's important to have that balance between tension and professionalism, I guess.
Yeah. I think it's always, there's a tricky aspect because it's audio is technical, but it's also creative. So, you'll come up with an idea or a solution, and you'll feel a lot of sense of ownership and like kind of pride in this thing that you've made. And it's difficult, like, as you say, generally people do well, but it is difficult sometimes to kind of hear that criticism as not like a personal, like someone attacking a piece of art that you've made would very obviously be like, this is opinion based and you're being a bit mean about it. Whereas, when you're dealing with that combination of like creative and technical, yeah, I mean, that's what I love about audio as well, is that overlap between those two things. But no, it's for the number of people we have, and we have quite a range as well, because there's like real absolute beginners, like, hi folks, I want to make a plugin, where do I start? And then we've got some like absolute heavy hitters who are like, I go looking for a paper to implement certain filters or algorithms or whatever, and then I'm just like, I think that person's on the Discord. you know so it's yeah, it's a very cool space.
Yeah, I love that. And I love what you said about how audio is this balance between technical and creative. And I think that you get a great balance of that as well in the talks that you do. So you've spoken for quite a few talks that we've done at the audio programmer meetups that we have each month. And you've also done several talks at the Audio Developer Conference, ADC. And one thing that I've loved about all of your talks is that they're so intuitive, and that they're this nice balance of almost taking the math and abstracting that away for a little bit as much as you can, and approaching it from an intuitive perspective. And I was wondering if you could just tell me a little bit about your creative process in terms of how you create algorithms. Do you approach it from that same perspective, or do you start with the math first? How do you go about creating and brainstorming unique algorithms?
So I think one of the things I like to do is to start with the sound that I want and then work backwards. And that sounds like a kind of, or almost like a trivial thing. But like, if you think about, if you ask someone what's a chorus, for example, and they might say, well, you've got these delay lines. And that's not a chorus, right? That's how you make a chorus. But like what a chorus is and what it does is like it does certain things to like the spectrum and like the input frequencies and that kind of stuff. And if you can think about that in as the goal, and kind of forget the steps of how you're meant to do it, then maybe there's another way. I don't think, I think you probably could make a chorus without any delay lines. I think that's perfectly feasible. But like, you're only going to do that if you're starting from the result and working backwards from there. And I think that's I think I have a lot of that streak, because of the way that I kind of mostly self-taught. I don't have qualifications in DSP at all. And my maths course, like, we did the calculus bits and everything, and so that gives me the equipment to read a bunch of papers or understand eventually the wall of equations on Wikipedia. But I think there is this gap between like the notation and the ideas of how it works. Like, there's like chess notation is another example, I think. You could be like, oh, knight or whatever it is, and there's like this shorthand for like, and if you're really into chess, like you read this, you can see the game in your head. But I think that if you try to teach someone chess with that notation, it'd be a nightmare, right? Because what you actually do is you can see a thing and it's moving, and there are rules about how it can move, right? It's a very structured set of things, and you're like, well, I want this to happen, so I have to set up these things. So that's kind of how I like to approach it generally, is this sort of start from the results, and then you've just got this like Lego box of interesting things, and some of them are like quite simple delay lines. And then you've got more complicated things. You've got sort of spectral or wavelet, or like calculus-y things and elliptic filters and all that kind of stuff, which are like when you really dig into them and you really start to get the maths like right in your face. But I think there's a lot of stuff where the rules of how you use it in like a consistent and correct way aren't as complicated as like the equations look. The equations are saying the same thing, but you kind of have to decode it. Like reading a programming language you don't know. Like it's just another way of expressing the same kind of algorithms and concepts. And so I think that's always that's where I come at it from. That like there's lots of tools, and it's not like tinkering as in like I wonder what will happen. It's like I'm 90% sure what will happen if I put this here. And you're sort of thinking creatively about what you think it should sound like. And then if you're wrong, you figure out why, and then that increases your understanding.
Yeah. That makes me think of what we were talking about just before we got online with how I was saying that when I think of things in terms of audio, I think of it from almost a product perspective or from a practicality perspective. And then I work my way backwards to the technical aspects of that. And it sounds like you're doing that, but at kind of a more micro level in terms of just the DSP algorithm. Is that right?
Yeah, absolutely. Yeah. So I'm not a great product person, to be honest. Like I'm definitely I come up with a sound that I want. And I've no idea whether anyone's interested or not. It's more like, I have an urge to figure out how to try and make a certain set of sounds and then make it. Or, someone else has the product and they come to me. But yeah, that working backwards from whatever stage motivates you, like you're motivated by the product. For me, it's I want the sound, and then I've got the tools to make that. But yeah, I think keeping your eyes on the prize is generally good, and I find that's quite motivating for learning as well, because if much as I said when I was learning programming that like I had to learn bits of trigonometry to rotate stuff on the screen, you can do a lot of stuff in audio with pretty basic maths understanding, and then every now and again you'll hit something which kind of stretches you a bit. And then you learn. And then sometimes you read something and you're like, nope, not touching that. And I avoided IR filters for a number of years when I was like teen, still learning in teens and early 20s and that kind of thing, because I was just like, I don't think I would be able to like write this from scratch. I haven't got my head around it, and therefore I was kind of. But there's loads of other stuff, I learned a bunch of other things that made more sense to me. And as long as you're learning something and you're keeping motivated, then that's definitely, yeah.
How did you break through that gap when you were saying that you were looking at IIR filters and saying, "Oh, I don't know if I could write that from scratch." How do you eventually break through that, or what was your strategy there?
I think the point is that I didn't have a strategy. I just didn't need it. And then one day I was like, okay, to make this next thing, I actually need an IIR filter implementation. And I, was reading through the audio EQ cookbook, that staple of the filter implementation world. And I danced around it enough times that when I wanted to do the thing that I needed IR filters for, then I could do it. But that's not to say that like the stuff I was doing before was kind of in order, if that makes sense. By that point, I was already messing around with FFTs and doing spectral stuff, because the maths of that made sense to me. It was all vector spaces and everything. And so it's not a question of like steeling myself to take a run up at it. It's finding the reason why you want to do something. And sometimes the answer is, well, I don't right now. But if there's something else interesting, and as long as you're learning something, then like I'm really like not very prescriptive about when you should learn stuff, as long as when you do learn stuff, you learn it properly. And not immediately down to the equations
Yeah.
straight away. Like despite knowing how the FFT worked as like as a thing to use, and sort of the perspective was on what it did to the representation of the audio. I didn't really look at the equation for the Fourier transform until my first year of university, which by that point I was already using the FFT in like Python script and doing fun stuff with it. And then I saw the equation and was like, yeah, that makes sense. And I think there's, yeah, that's sort of, I don't know if that made any sense.
It does make a lot of sense. And it really makes me think about the way that I learn as well, and the way that I've actually advised other people to learn in the past when they talk to us about getting started with audio programming, which is that it's very difficult for me to pick up a C++ textbook and just turn to a page and really, let's say, pointers. And without having any type of use case, just in isolation, to take that concept and really, it's not that I'd have trouble understanding the concept itself. It's more that it's more understanding, well, what's the use case for that? Yeah. So if you go to any pointers tutorial that you find on YouTube, people say, well, what's a pointer? Well, pointer is just a pointing to a memory location. It's like, well, what does that actually mean in terms of practicality? But when you start talking about having assets, so a lot of times I use the analogy of a game to illustrate how you have certain things that need to be loaded up, like maybe you have a game scene and that you don't need the game scene throughout the lifetime of your application. And so you set up this game scene, and so you allocate some memory, and then after you're done with the game scene, you tear it down and you destroy it. And then to me, that makes things much more intuitive. And it sounds like you approach things similarly in DSP, in that maybe it's all about just all about just moving forward with a project, hitting a wall, and then saying, well, I need to learn that concept in order to break through this wall. And then you learn that concept, you keep going until you hit another wall. What do you think
Yeah.
about that?
Well, I think the elephant in the room here for me is that I do have ADHD. So the idea of just like deciding something is a good idea and then just grinding through it is just never going to work for me. That's fundamentally incompatible with how my brain works. So yeah, like being in that situation where you need something because there's something beyond it that you want, and you can kind of feel it getting closer. And getting that feedback as like things come together is yeah, that's always been part of how I've learned, and I guess how I like to teach and share and communicate with other people as well. But it comes from my brain.
Yeah. Can you tell me a little bit more about that, about how ADHD manifests itself within your programming workflow? Because I'm sure that there are some other people that are curious about programming workflows in general, and just being able to sit in front of a computer screen and just bang out some code. So tell me a little bit about your workflow and how ADHD comes into that and helps or hinders that process.
Yeah. So I think the first thing I want to say, if anyone is listening to this and being like, hang on, this is familiar, like a life lesson, which it took me a while and support from my partner and various other people to learn, is that like if you're finding something really difficult and you feel like you're failing, I used to beat myself up about a lot of stuff for that kind of thing for a while. And it has made my career quite difficult because there were times when like I could do the work in like a practical and knowledge sense, and I just couldn't get myself to actually do it. And I thought that that kind of was going to make me like a dud, you know, a bit of a write-off, doomed to underperform. And actually, what it meant was that I needed to get to the point where I cared about what I was doing. And that for me is audio, and I found that, and I'm now kind of absolutely on my home turf. So part of the problem is situational. That like it makes you less flexible in terms of like the type of things you can choose to do, because there has to be something in there. Like you can't really grind through work for the money if that's the way that your brain works. In terms of the way I kind of approach stuff, it definitely I really appreciate abstractions and that kind of thing, because, and I guess this overlaps a bit with the way I think about maths and learning and that kind of computer side of it as well. Sorry, math side of it as well. But I don't have a great memory. Like I can't do facts and figures. I was terrible at history. I'm still awful at mental arithmetic. You saw me failing to multiply something by 3 earlier. And like in some ways I have quite a small brain. As in like I'm not dumb. I just can't hold a lot of stuff in parallel. Um, and what that means is that like I have this compulsive need to make everything simple and to like fully understand something so that I can put it down and not need to hold it anymore.
Mhm.
And there's a lot of audio and DSP where like there is hardcore maths, but like actually when you get down to it, hardcore maths is like ideas, it's advanced chess moves, it's that kind of there are rules to the system. And if you can understand them instead of remembering them, then they're just like a lot smaller. I can't remember the name for any theorem, really. But if you know how it works, then you kind of get to this point where it feels like you're using simple ideas. It's just that those simple ideas are things that you have digested over a number of years until until they feel simple and flexible and powerful. And I think that that's sort of when you're trying to learn from someone who doesn't think like that, there's often like a bit of a flood of information. And so with my presentations and blog posts and everything is very reflective of how I think, which is A, this stuff is fun. Like you can have fun doing this, right? And B, that like the pieces that you're working with aren't complicated. Like you don't have to know how to make a spanner. You can start using it, and then after a while, you can probably like take a guess at like how everything fits together. But like you don't need to think about that when you're using it, if that makes sense. You just kind of like it's shapes of tools and rules for what you can and can't do, and what moves you can make, which actually feels like it's very simple. And I try and communicate that simplicity where I can. So yeah, the main problem is that like even whenever all the individual bits are simple, then it takes a while to cover them. But with my coding practice again, like things like object-oriented programming or templates or that kind of thing, where you have something that does the job that it does, and you've tested it with automated tests as far as you can, and then you just kind of forget about it, and you write your own documentation, and you will be the person who reads that documentation more than anyone else. Even if no one else ever reads it, you should document it, because then you can forget about it. And so, yeah, abstractions and documentation and kind of a clean organization where everything's like compartmentalized so that you don't have as much stuff on your mental desk at a time is, yeah, I think that's pretty key. And I don't know whether that's, I wouldn't say it comes from like an advantage, but it has pushed me to have to do some stuff properly, because otherwise I just get very confused really easily.
Mhm. So it sounds to me like a little bit almost like a martial art in the way that you have, I say martial art because I've been doing jujitsu recently.
Mm.
And one thing that I've found is that in jujitsu, you have this combination. So it'll be like, okay, it'll be a sequence of moves that happen in succession. Now, for me to fully be able to do that, I need to have a good understanding of why that's happening at that particular moment in time. And I need to understand that whole process. And it sounds to me like there's a similar type of thought process that you have there, where it's like you have to understand everything about it. And maybe in the way that we do in martial arts with visualization and with repetition, it happens in DSP algorithms for you with documentation, being able to write down the intuition and being able to write down the reason why you're doing certain steps at a certain time. Is that right?
Yeah, yeah, I think, and an analogy which might be, I'm not, because I don't do jujitsu, but after a while, does it kind of feel like at, at a certain point you stop consciously thinking about where your feet are, and you instead want to be like, well, I want my opponent to be slightly here, and you've got like a toolkit with you which you're not really thinking about. And so it's all about building up that kind of toolkit that's like right at your fingertips.
Yeah. It's almost like a
And
language in a way.
mm,
It's almost like a language in a lot of ways. I think playing an instrument is another good analogy that I think probably more people may be able to relate to, in that when you when you first start an instrument, it's about the technique, right? Just being able to learn one of the fundamental techniques, and you're just learning your first fundamentals, and then over time you're able to chain fundamentals together to form larger abstractions that contain two fundamentals, uh, into a larger language.
mm,
In martial arts, it's the same way. So you may have you have certain positions or certain situations that, if you're just starting out with, let's say it's jujitsu, you may be just starting out in one position, and that's all you know. And then in isolation, you do another lesson that may start you out in a second type of a different position, and you learn that in isolation. But then over time, you learn to chain those two things together to make them more into almost a dance, or more into um, a larger um, a, a larger art, a larger act, I guess.
I think that's cool that it works for you, but like that's actually, I think that sounds quite different to how I like to learn, because rote grinding of fundamentals and then gradually building up in complexity is absolutely not the way that I can relate to. Like, and I think one of the fun things about audio is that like you don't need very advanced stuff to make something that's incredibly fun and like genuinely useful, right? A lot, in a martial arts thing, like if you've been doing it for 2 years and you're in a sparring match with someone who's been doing it for 20, then you're going to lose, full stop, right? And one of the things that's like really fun about audio is that like there's some technical stuff that keeps opening up more and more space for you, but every now and again, like your creativity and your motivation and your personal motivation for like what it is you're trying to make, which isn't like a rote, you do it in this order kind of path through the material. You can make really cool stuff with very basic building blocks. And I actually don't think that rote, like getting that muscle memory almost is a way for everyone to learn. Like some people are going to really respond to that, and some people, including me, absolutely don't. And it's almost like leapfrogging and kind of, it's not really cheating, but just like being allowed to put something aside because it feels like it'll slow your momentum down is very important for me. And I think sometimes people need permission to do that because they want to learn to do something properly. And that's great, but like doing things properly is like a 10-year goal, right? Um, that like you'll get around to it eventually.
Mm.
And you know, you don't have to learn the very depths of the basics of like subsample interpolation or whatever to make something cool. You can just be like, well, that works. I've got this bit. And then like eventually you'll come back to it with like more understanding and you'll be like, oh, that's how it was working all along. Um, but like, you know, you don't necessarily get to the finish line faster by doing things in ascending order of complexity by like someone's metric. So yeah,
So
I
how
think
do you
hmm.
so how do you know when it coming back to DSP again, how do you know what those basic building blocks are? How do
Uh,
you discover those?
part
Or
of it,
how does one discover
yeah.
those?
Um, I mean, I did it the hard way, which was like Googling and messing around and experimentation for like years as a teenager, and it was incredibly inefficient. Um,
Would
Nowadays, I
you
just say, hop on the Discord and ask someone. Um,
would you say it's going back to that what you were saying earlier about working backwards, looking at something that interests you, and then trying to break that down into smaller steps or smaller I don't want to
yeah,
say fundamentals
that's
fundamentals
the
sounds like
thing. Like fundamentals implies a certain amount of like, uh, yeah, like completeness, I think.
right. Mhm.
But it, like you only need the bits of the foundations that are holding weight, right? Like I a while ago I had a like summer work experience person who was kind of uh and they came along and I was like, what do you want to make? And they were like, what are the options? And I was like, well, off the top of my head, here are 6 things, like which of them resonates with you. And this is someone who they had been learning Python. They just started C++ and they had not done any audio. And they were like, actually, that noise reduction thing sounds quite interesting, right? What, you know, noise reduction, that's like step 30, right? You've got to have all your, you know, your complex numbers first and all that kind of thing. And actually, you kind of can get away with um, if you have the right resources and the right help and the right people around you. I was again lucky to have my dad, who also works in signal processing. He does the analog side, sort of electronics and chip design. And so like he was a great resource for me when I get curious about something that was way beyond where I was. But you can grab the corner of it. Um, so yeah, like this chat was with me for 3 weeks, and he wrote a noise reduction plugin, which is
Interesting.
just really cool. And so like yeah, the idea of fundamentals, like I think is absolutely fine to kind of specialize in the things that interest you, and then you'll start to step sideways eventually and realize that you need some other stuff, and you'll dig into it, and you'll have that motivation because you've already made something really freaking cool that then will have this extra feature if you can, you know, figure out how to make it work. So, um, yeah, absolutely not a fundamentals first person. I believe in rigor. Like I think that the things you're learning should not be approximations, and it's our job as the people who have made it through the weeds of like you know the hard understanding to help people kind of get that momentum and that kind of thing going quickly so that they can have a correct, if slightly like hand wavy view of how these concepts work and how you can use them.
So going back to that description of I'll call him an intern. I'm sorry if that's not the right term, but work experience. That they're writing this noise reduction algorithm. Are you saying that this means that that he or she is taking certain parts of that algorithm or certain parts of that process and saying, okay, I'm going to pop this thing in here and I'm going to move on with the understanding that I don't fully understand what is happening in this particular area, but that in the interest of moving on and keeping things moving forward, that I'm just going to leave that right there, and that's
Yeah,
going to be
so
okay.
to make that plugin, they had to use FFTs. And like they weren't super hot on linear algebra at the time, like sort of sixth format, sort of 17 or something. And you know that you haven't done a lot of it, and you definitely haven't like hardened those synapses to like really optimize it. So, but the point is like you don't need to understand everything about how the FFT works. You can be like, well, you give it a chunk of stuff, and then you get this other array,
Right.
which is like another perspective on the same sound, but you have to like kind of convert it back before you can use it.
Right.
But like, you know, if you understand harmonics, and so we did the thing where like, oh, we'll set everything above index 50 in the array to 0. And they go, oh, it's all muffled. And we're like, yeah. So like these later bits, they're kind of like the brighter bits, and these are the and particularly if you're in something like Python, you can plot stuff. So that's nice and visual. But yeah, and we like they've done some complex numbers, but like I was like, you don't right now need to really deeply get what the phase of this complex number does, because we're just going to look at the amplitude right now. Here's how you calculate the amplitude. And then you're like, well, this is the amplitude I want because I've like subtracted some noise amplitude, and then just kind of multiply a bit. And like I was there. I knew which bits of the path you can kind of like cut through um, while maintaining that. So like I don't think that they would have been able to do it if just left on their own, and that's why this kind of community thing is important. But yeah, like the FFT was a black box. Like the linear algebra bit of that, you just don't need to engage with it to make a spectral effect. And then like as you learn more of it, then eventually like your ability to do new and creative things with it from scratch, like evolve. And you'll understand like what phase does. And you know, there are some things which you really need that for. If you're going to do time stretching, you need a phase vocoder kind of understanding of like what that's doing. Or you can just randomize everything, and then you've made pull stretch. Congratulations. And that's still a cool sound. So like, you know, there's very much there's always something you can do, and I wouldn't let your like, yeah. So I don't think that they needed to. You don't need everything down to the very floor to be able to build on it. You can bring in these black boxes, and then if you're interested in, which you will eventually be, then you'll dig into them. You know, like I use the FFT and understood how the Fourier transform works, and then I guess a couple of years ago now, over Christmas at some point, I was just lying awake in bed. I was like, oh, I think I could write an FFT. Like I really wanted to get my head around what like the fast Fourier transform, like that optimization was doing. You know, it's something I've been using for years. I'm like, well, they make it fast somehow, magic. It's fine. Something coolly chooky, blah blah blah. And then one day, you know, I woke up and was like, today's the day. I'm going to implement the FFT. I'm going to understand it like top to bottom. And you know, I've got some of it. I don't have like the Bluestein Chirp Z stuff, so I can't do prime numbers. But that's like the point is like I'll get around to that eventually when it becomes interesting. And until then, like if you understand the rules of how you interact with something, then you don't need to know what's inside it. And like sometimes that if you're writing it yourself, that's like creating those abstractions for yourself later, so you don't have to go and remember what's inside it. But if you're using other people's stuff, if it's like properly documented as code or as maths or as a concept or a chess piece, then like the rules of what you can do with it can be understood and followed, and you can build an intuition around that without having to build it from the ground up. You can get your intuition that comes down from the top. And then one day your maths will come and meet it in the middle, and that's when something really fun happens. But like, yeah, you can just, don't be ashamed of like looking up the cookbook to implement something. Yeah.
Do you use any large language models in your daily workflow, like
No.
ChatGPT,
No,
Copilot?
absolutely not. And I'm worried I'm going to become a Luddite curmudgeon here. So I'm not on a campaign against AI, but every time someone occasionally comes onto the audio programmer Discord and they say, I asked ChatGPT to write this for me. Can you tell me why this code's not working? And I think that that's kind of AI is sort of the point when if you're using it to kind of accelerate stuff that you're pretty sure you'd know how to do already, that I think is kosher. But I think if you're using it to kind of fudge something that you only half understand, then like the point where you use AI or machine learning is kind of the point where your understanding stops. And you've volunteered to stop understanding there. And I think that goes for both asking it to generate code for something that you wouldn't really know how to write yourself, and also at the kind of the high level of these like audio generation models and all the kind of the new frontier of AI. It's you can do incredible stuff with them, but you have to be the person creating the AI tech. You have to be the AI researcher to be able to improve it past that point, because kind of you've got a black box that you can't open at that point. You can't look at like a trained language model and like look at the coefficients inside it and be like, oh, I understand more about this now. Like it is by its nature opaque, and I think that no disparagement to people who use it, but I think that it's probably good to go as far as you can without it. And then if you have used it, like see if you can replace it. It's it extends your reach a little bit, but doesn't help you like grow your understanding or progress the project or whatever. That kind of it's the end. That's AI is where the bounds of your project end, I think. At least that's my personal take, and I'm sure I'll get some comments about it. But you're all wrong, and I'm a mod now, so I'll ban you.
You have the power.
I have the power.
Do you think that when it comes to large language models, that it'll always be like that?
So because I don't have like the deepest interest in it, I don't want to speak with too much authority on this, because it's not my specialty. I think that the way that they're currently made is by ingesting a lot of data kind of blindly, and then as Neil Gaiman put it, they don't know anything, but they're very good at creating fact-shaped sentences. And it takes a lot of data to do that kind of with any degree of plausibility. And so I think that if we want it to be more understandable, then the models themselves have to be less blind and dumb about like how they consume the data. Like there has to be more structure in the way that they ingest the things. Like something like Alexa, like there's a knowledge database behind there. And they've coded in certain types of relationships so that you can say, who is this person's father? And it will kind of like look through its database of knowledge and see if it has like a Wikipedia entry about that and that kind of thing. And that's, you know, there's that structure in there, which makes it kind of more reliable and more, yeah, more robust and future-proof, I think. But whether we can get to that, I don't know. It's not my area, but I'd be, you know, curious to find out.
As a person who has a great intuition for math, have you ever had any curiosity about exploring machine learning algorithms, as in learning that area yourself to implement within plugins or implement within?
I mean, I've implemented neural networks and various optimization algorithms and all that kind of stuff. Like, so it's not that I haven't engaged with it as like a theory, but like the fundamental way that like AI or machine learning stuff, like the whole training thing, is that you have a system that's complicated enough that you think there's probably some configuration of it that does the thing that you want. And then you clearly define what success looks like, and then just kind of like keep tinkering and hammering bits of it like in an automated way until it produces the outputs that you want. And like there are simple versions of this, like machine learning used to be a lot simpler. And then as those things got solved, they stopped being machine learning once we understand how they work. So yeah, I think that yeah, like it's again, I've got a very mathematician's attitude here, actually, of like I understand in theory how it works and have no interest in doing it in practice.
Yeah.
And not that I'm against it, like there are really cool things to be done with it, particularly when combined with more like informed models of things. Like one of the examples would be if you do like frequency analysis, then often and like a lot of the techniques generated like the kind of the image, like this the spectrogram, but there's no phase information in the spectrogram. But there are some really cool techniques like sort of Griffin limit iteration and that kind of thing for like creating a phase for something that matches like a magnitude only response. And then that's kind of interesting to me, that kind of interplay between you've made something that's slightly unusual, and then you kind of there's an interesting bit of understanding in like making it practically work. But the neural network synthesis is not personally my bag, but there are cool things coming out of it, so I'm absolutely not going to knock it.
Yeah, where do you think the future of plugins, pro audio, music creativity is
Ooh,
going now?
that's an interesting one. I think for a while now, we've been in this area where, in theory, additive synthesis or like that kind of processing can do everything. You can generate any sound by like adding together sine waves. I mean, in theory, you could zoom in and draw the waveforms with your mouse, but like there's you can output any series of numbers you like to the speaker, and then the question is how you get there. So I think the two fronts on which there's like innovation, I think, is like computers do keep getting faster. So there are like techniques we can use because a lot of the innovation is like you've got this open field, but like actually just brute force calculating would be really rough. Like I have a project at the moment where one of my early prototypes ran at about 100 times slower than real time because every 3 milliseconds it was inverting a 1,000 by 1,000 matrix. And it was just like, but I think there's a way I can kind of, if I can find out how to improve that or like approximate some bits of it or like figure out which bits of the model are relevant and cut it down. But as the kind of processing increases, there's always that set of stuff that you can do now that would have been infeasible. And then the second thing is just like how you control it. So, Sudara, and they're making an additive synth, which is getting some lovely sounds out of it. But like, yeah, additive synthesis has been done before, but I have not heard something that sounds like Sudara synth because they came at it with a very like a particular idea of what sounds they wanted to make easy and the techniques they were experimenting with and like which things you try it and you're like, eh, and which things you try and you're like, oh, yeah, I'll lean into that. You know, that kind of exploration is always going to be there. And in the way that like, musical tastes are always shifting, like a good sound, an interesting sound is it can never be a completely solved problem. And so if you make different things easy for the user, I think that's where the innovation will continue to be. Yeah, that's kind of my feeling about at least which things I'd be excited to play with in the future.
So it sounds like you don't feel that we've hit the bounds of all the DSP algorithms and that are out there, that there's more to discover.
One of my favorite things I saw on the internet was I can't remember his name, but like sound designer who in Faceplant made an incredibly accurate simulation of an electric drill going into a wall. He goes, I'd say beautiful. It's not. It's a horrendous sound which no one wants to be woken up by. But the point is, it's very impressive. You can do anything in Faceplant, but like most people couldn't. He can do anything in Faceplant.
Yeah.
So in a way, everything has been done the moment that programming languages were invented. Like I was outputting sine waves from QBasic back when I was like 12 and like making my little patches. But I think that yeah, the innovation is not always like the space of things we can already do in theory is so much huger than anyone can navigate. And so there's a lot of like, there's a forest there, but you don't know what's in it. And like going and finding out the bits of the landscape that no one's actually like written a map for, so you can get there really easily. That kind of thing is, I think, yeah, like whether something's been solved is a very like, I don't know, a dismissive kind of attitude to it. Like, because I think that there's, yeah, as I said, anything's possible by adding sine waves together. But like, practically, that's not going to get you very far, and it'll be really slow to use. And like, at the end of the day, we make tools for humans, right? And well, unless you're doing differentiable DSP, at which point you make tools for the machines. But like, generally, we make tools for humans, and so like a lot of the innovation and like the progress which will always be there is like a new sound that's easy to make, done in an interesting way so that like its own quirks and stuff kind of naturally push you in different directions. Because that's a bit like saying, well, I can write out the entire alphabet, and so all of writing is solved. That's not really how it works. So, DSP is, I think, it's a creative field. It'll be endlessly interesting. Not to say that there aren't a bunch of really boring plugins out there, but I don't think that's because we've run out of things to make.
Do you think that a lot of the plugins that are out there are just using bog standard algorithms that aren't really giving a lot of character, a lot of value to the customer? Is there a lot of character that's coming out through plugins nowadays, or are we just Or we just um, are we just imagining a lot of the effect in our minds? And
I think there are subtleties which kind of add up over time. So like if as an analogy, if you've got like 5 effects in a row and each of them introduces like a small error, then by the end of it, the result's going to be just a bit less clean, right? And so some of the attention to details are, as in our role as audio programmers, is to kind of, yeah, you care about like little bits of aliasing, because if you then put it through something else and then put it through nonlinearity and blah blah blah, and then it kind of it'll sound wrong. It'll sound a little bit more grating in a way which like it's hard to pinpoint for the end user, but they'll just somehow get different results from it. And so there is definitely like there's a range of stuff that's doing it properly is still valuable. Caring about the small details is valuable. And also, I know I'm a DSP guy, but interface is hugely important. Like on the theme of making tools for humans, like FabFilter, people love FabFilter, and like they have this, like the first people I've seen at least had a kind of cool overlay of like the different bands, so you can like see what each band is doing, but also then how it contributes to the overall shape and that kind of thing. And it like people feel good when they use it. Like, and yeah, if you've got like some nonlinear what's it, or you're doing like dynamic EQing or something, then like there are details of like the character of the sound there. And if they've got the different filter modes for like handling the high frequency cramping and like all that kind of stuff. So like there's technical stuff they've done right. There's some stuff where like the sound really matters, and there's a lot of stuff which is just like you could use any EQ, but you're using it because it feels really good. And yeah, like if you make a one knob plugin that just kind of makes things sound like funky, then yeah, that's great. If it helps you make music, like that's yeah. So some stuff is just they've put something out there and they're trying to generate that sense of like involvement and creativity through marketing or like tricks or whatever. But there's stuff that like you can make the same sound in 2 plugins, but one of them's a lot better because it's easier. I'm trying not to mention Linux at this point, but like I'm a great fan of Linux, but you can do anything in it. But it's not easy to use. So I use a Mac because it's closer, but it's shinier. And sort of it's very I think that's how I feel about it. That
so the algorithm is one piece of a larger puzzle, but there's the
yeah.
interface, there's actually the marketing, there's the intuition in terms of the user experience.
Yeah. And that's if the sound is the same, and there's still huge scope to make the thing that's different on top of that. I'm just saying that like if you've made something that's been made before, like it's not necessarily a bad idea or or already done. You can still put a twist on something that's based on how you feel and how you want it to work without necessarily having, again, the deep maths background to invent something weird and perceptual and blah 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 from scratch. You can do a good basic, and it's really valuable.
Yeah. It's interesting that you say that because I have an agency, of course, as you know, that we have teams of developers that work on products for clients. And it's interesting how invested some of the people that I work with get over a product. So clients come to us all the time with different ideas. Of course, Most of them, all of them, have been done before in one fashion or another. And sometimes developers come back to me with feedback and they say, "Oh yeah, such and such plugin does that, or this other plugin does that." And I say, "Yeah, maybe it does, but this person may have a unique vision on this product that, with their particular brand, with their particular vision, with their particular ideas around user experience, it can end up being an entirely different product." And it's actually not our job to figure it out. It's the client's, it's actually the client's job
Hmm.
to give us that vision in terms of how they want that idea to come together and how they want that idea to be manifested. I mean, we are their hands, but just because something has been done before or feels like it's been done before, it could be manifested in so many different ways. And look
Hmm.
at, I know that you're not a DJ, but if you look at DJing apps, you have different apps like Serato, Tractor, Virtual DJ, Algorithm, all doing essentially the same type of job, but the user experience behind just those four pieces of software is completely different, with four different ideas and principles that differ from each other. So I
Yeah.
hear what you're saying in terms of
Hmm.
there are many ways that you can take the same ingredients and mix them up in a different way and come up with a
Yeah.
whole different recipe.
It's not always going to be a winner, but it might be.
Right.
And
And you
like,
don't need it.
yeah.
You don't need it everyone to be a winner either. It's just you do it, and once it's out of your hands, it's out of your hands, and it's going to
Hmm.
be what it's going to be, and you just go back and you write another one. It's kind of like writing music in a way.
Hmm.
People, I think sometimes people they defeat themselves in terms of trying to come up with that magic ingredient or that magic thing. And um, it's really about just writing and getting better over time. Because you can just psychologically you can defeat yourself, and
Hmm.
you can trick yourself. What really interests you in terms of DSP right now? What are the things that
Ooh.
you're thinking about in terms of digital signal processing?
Um, it's a really good question. So I've always been drawn to kind of spectral stuff, because for me, it feels the closest to just being able to like generate sound from nothing. Like I want it to sound like this, you kind of almost paint the sound you want. And I find that really compelling, and there's a lot of flexibility in it, but also like a lot of subtlety, which is like fun to wrestle with. Um, yeah, personally at the moment, I've been looking at like kind of that boundary between spectral stuff and like latency, because like that's a bit of a trade-off, um, usually there, and sort of um, yeah, stuff that's like in between time and spectral kind of processing is where my head is at a lot. Yeah.
What are the most challenging areas of DSP for you?
For me, oh, well, the challenging stuff for me, it would be like an accurate emulation of some piece of hardware that I've never used. Um, but I'm in the privileged position to just be like, well, I wouldn't be interested in that. It sounds really boring. But there are people who are really into that. So like that's great. So like um yeah, I think that the question almost doesn't make sense, because like the stuff that I find difficult is the stuff that I don't want to do. Um so yeah, the stuff that I find fun and compelling is like, got some really hard, chewy maths in it. Um
Right. But maybe
yeah.
not so much in terms of what you don't want to do, but in terms of the most technically challenging for you. If somebody just came to you and said, "I want to do um, X," what would that X be that would be the most challenging for you? Where you say, that is a really tough area for me.
think again, I'm gonna have to just not answer that question because like I know you tried to get a different answer out of me, but like still fundamentally, if someone comes to me and says, here's a problem, we want to do this, and I'm like, I have no clue how that would be. Actually, I have a theory. Actually, now you mention it, I did an experiment 7 years ago. Actually, yes, please. So that is always like kind of how it works for me, that the stuff which is like seemingly impossible or like inscrutable on its surface, but there is something really that's your open field. And for me, like creating an algorithm from scratch, that's the dream bit of my job. And
So you enjoy the challenge. You need the
I
challenge.
enjoy, yeah, I need the challenge. Yeah. Like this goes back to me like right at the beginning when I was talking about like if you're feeling like you're failing at something, you might be like just trying to do the wrong things. But I was really, really bad at yeah, certain bits of programming work, not because I'm a bad programmer, but because I was bad at like the doing bit. And actually I needed to be given harder problems in some sense to suddenly be good at them. Um, and I think that's still the case for me. So I know that's absolutely not the answer, but like, you know, I chose pitch shifting for one of my talks, partly because it's like a really interesting area and there's like a bunch of different approaches you can make that I kind of put together into like a narrative of like um different ways to think about sound and using pitch shifting as an example, but also because it just sounded like a hard problem, right? And so I was like, I'd love to take a swing at that. Like, and I did. And now I'm really comfortable with it. And I'm sure in a couple of years I'll be bored to the back teeth of pitch shifting and I'll be like, oh, off on some other technical thing. That's again the privilege of where I am and the uh the way that my brain works in particular, like kind of drives me to that kind of working practice. But yeah, so still the most difficult things to do are the things which aren't interesting.
Yeah. Okay. Looks like we have to wrap up soon, but maybe just one or two more questions. C++ and writing DSP in C++. Do you enjoy it? Do you find it to be painful? What are your thoughts on it?
Hmm. I I have a very strange relationship with build systems. So like if you're
We all do.
well, you say that, but there are people in the Discord who like, they can write CMake files, they can set up like continuous integration and all that stuff. And I'm just like, salute you, because that's so far from stuff I like to cope with. Um that like that kills my productivity. Like if a build's not working, then like not just the time, but the motivation just like zoom, immediately disappears. Um, but C++ as a language, actually, I quite like it. Um, I think because it's very much like it feels low level, and you can almost kind of there are some nice abstracted kind of concepts, but in a way, if I were writing this language as a layer on top of C, how would I make this feature? That's pretty probably how it works, right?
Mhm.
Um, so if it's on that kind of um, boundary between like uh, complexity and like power versus still being remotely usable. And yeah, it's possible to shoot yourself in the foot. Maybe everyone should be using Rust. Um,
Mhm.
maybe the one of the contender audio specific languages is like the future. As it goes right now, you can use it sensibly and be pretty reliable, and it's just kind of it's the lingua franca of programming at the moment. So
Yeah. Have you tried Rust?
uh, only enough to get me simultaneously excited and scared.
Uh, and when you're prototyping and exploring ideas, do you normally do that with C++ or do you try other.
I do now, yeah. So like, because I'm impatient, the main thing that I really want is that kind of like that immediate feedback. So I have now got my build system set up. I don't touch it. And actually I do a lot of stuff that's like in the browser, because actually compiling to like WebAssembly and that kind of stuff, like I've got a setup that works quite well. You can just kind of, the build time's really fast for that. But also like, I think because of the stuff that I do, my experiments tend to be quite computationally intensive. So there's not a lot that I can prototype in Python or that kind of thing. And so I've made a few things easier for me. Like I've got like a C++ plotting library, so I can still get graphs and that kind of thing. Yeah, I do use C++. I'm not gonna hold it up as like the language that everyone should be using. So if something else works better for you or feels less intimidating or scary or dangerous, then yeah, do that. Momentum is key. So like I don't copy me just because I sound confident doing.
Right. Just waiting for some questions from our viewers right now. Elanda, who you know, asks, "Why are you so sympathetic?"
Might need more context for that. I think that like almost never when you're like when there's like a conflict or like something's not working or someone's not understanding, it's just like something's gone wrong in communication. And like I think the Socratic method, which is a very fancy term, but just like there's if someone disagrees with you, then like either it's an opinion, like film reviews or something, or it's like hard facts, and one of you is wrong, and you've got to remember it could be you. And the way to find out is to ask them to explain the things that you think their system might break. And you might be surprised that it doesn't, and that your thing actually does worse. And so the technical side of that is always just like, yeah, just get better at communicating. It's a tricky problem. And the internet made it a lot worse just because there's a lot of stuff in text now, and you can't read like tone very well. And so stuff that like sounds really aggressive, like it's easy to get kind of inflamed about all this kind of stuff. And I think it's just, you know.
They actually have whole books that are written about how to communicate online and through email and how to. It's very interesting. Yeah, I've been reading a couple lately. Joaquin has asked about the C++ plotting library that you've mentioned. So that's an internal tool that you've built, correct?
It's on my website. If you go to signalsmith-audio.co.uk, or just search for Signalsmith, because I said there's only one of me, but I couldn't get the co.uk. I couldn't get the Signalsmith domain because some person who installed TV antennas still had it. But yeah, it's a C++ tool. It's open source. It's on GitHub. I've got some. It's not super documented or super like rigorously tested, because it's not something I use in production code. It's like for me, it's a debugging and like development and R&D tool. But there's example code out there. So like, yeah, look it up if you're interested.
Right. I don't want to try to pronounce this person's name, but somebody asks, are there any new Reaper.js plugins in the making?
Reaper. So I actually have not really gone back to Reaper stuff since I started moving over to C++. I was really into it partly because, as I said, I don't have a great relationship with build systems, and the idea that like Reaper it was all done internally. It was like compiled at the time. It was built into the Reaper software. That made it really, really nice for me. And then what I found was that after a while, I wrote a preprocessor so that I could use something closer to like C-style structs in the JS language. And after using that for a couple of effects, I was like, I think maybe I'm doing something wrong. I think I might be using the wrong language. So probably not going back to JS, although I still love it as a language. And if you have any questions about like the stuff that I have written, or like people still give me like suggestions, that kind of thing. But I've personally moved over to C++ because I was starting to feel the constraints of the language a bit.
Right. Yolanda asks, is the PSOLA accurate enough for a pitch shifting plugin? I have read that it is not accurate, whatever that is supposed to mean.
So there's when you say pitch shifting, there's still like subcategories within there. So the stuff that I gave a talk on was all like polyphonic. You've got like more than one note happening, guitar or piano or whatever. Or in fact a full mix, they're like percussive and stuff all mixed together. And on the other hand, there is when something's got one note happening at a time. And that's the kind of stuff that Solar is good at, and it's very low latency, and like again, like the vanilla version of that is it's a bit naff, doesn't deal with inharmonic stuff very well. You have the pitch tracking is like a kind of an ongoing problem, but like that's, you know, there's a simple version of everything, and there are a bunch of extensions, and fundamentally any auto-tune-ish kind of plugin, any monophonic live pitch correction with a low latency is very likely, not certain, but very likely to be using something related to the Solar. And so yeah, I think it's still a very useful tool, but you know, innovate and get creative beyond the basics there, because there's room for it.
Great. And one more question from Sama, very interesting question. I think it's two questions in one. With the possibility of cutting the worldwide internet in the next couple of years, what's the future of audio programming looking like?
So the possibility of what?
Of audio programming.
No, what was that? What are we doing to the worldwide internet?
It says, with the possibility of cutting the worldwide internet in the next.
Are we becoming federated? That's fun. I don't know. As long as people can connect and we can share knowledge and algorithms, like we'll make it work. We care enough. It's not going to stop us.
I think if the internet gets cut off worldwide, I think we'll have bigger problems to think about than what DAW we're going to use.
Yes.
One more question, actually. So this is from Anirudh, who says, very new to this world. Can you tell me in simple terms what a DSP engineer actually does?
Okay, so sound is, in the way that we perceive it, like it's sort of pressure waves in the air, right? Or, you know, it's the movement of a speaker cone or whatever. So like the point is there's a value you can measure over time. And like how that changes in cycles or patterns or fast or slow or whatever, like that's your waveform, that's your sound. And like DSP as a field is, instead of like a wobbly graph, you get like a bunch of numbers that represent a segment of the graph. And our job is to take little chunks of those numbers at a time and then output different numbers that sound different in a way that someone wants. And that's super simplistic. But actually kind of that, I mean, that's the core of it. And like, there are some basic principles you can kind of like sink your teeth into, like things that move fast, it takes high frequency stuff to like do it. So if you kind of just blur everything, kind of like smooth it out, smudging, like averaging values, then it gets all waffled. So, you know, that's the principles, and just like it's a bunch of techniques for figuring out how to make up new numbers that sound different. And that's why it's so like wide open. And like my particular corner of being a DSP person is very different from some other people's. Like, you know, some people are like, they want their expertise is in like tuning latency of embedded systems or that kind of thing. And I tend to get called in because someone wants something where like the algorithm or the maths is like tricky, or they want something creatively done that isn't obvious how to do it for their in-house team or whatever. So yeah, it's quite varied, but like yeah, and my bit of it is very much like algorithm consultancy rather than like, you know, reference implementation. Like it goes into products, like I ship code, but like it's you know, there are lots of niches depending on which bit's really call to you. I hope that is an answer.
That sounds like a great answer. And before we wrap up, where can people find you? So you said, I did say that you were world renowned. So when you Google Signalsmith, there is one Signalsmith that comes up. Where else can people find you?
So yeah, I also have a globally unique person name, but you have to spell it. So that's the downfall. Yeah,
That's your test. Can you spell it
can
correctly?
you spell it? Yes. Yeah, so I'm on GitHub. I've got my website for Signalsmith Audio, and you know, my email and everything is on there. But like, if you actually want me to reply quickly, then yeah, give me a ping on the Discord. Sign into the audio programmer. I'm Signalsmith there. Occasionally check Twitter. Not really. Oh, it's not even Twitter now. And yeah, don't message me on LinkedIn if you want to hear back in a reasonable time frame. I'm not very good at checking LinkedIn. But yeah, Discord, email, carrier pigeon. Yeah.
Yeah. And if you're not part of the Discord yet, then be sure to join us. You can join. Yeah, you can reach out to Signalsmith directly via our audio programmer Discord. You can join via theaudioprogrammer.com. Also, Geraint is going to be at our event in London on the 30th of August. So you can catch him live in the flesh in London, 30th of August. That's at CodeNode in London. And if you aren't able to fly out or take the train to London, then you can always catch us online as well, because we'll be streaming online, and he'll be doing his talk about Hilbert filters. Very interested to see that. And with that, we will go ahead and sign off. Thank you very much for everybody that tuned in, and we will see you next time.